Hello Year 7, today we are going to look at neutralisation, and that's a reaction between an acid and a base, and these reactions always make a salt plus water. They're called neutralisation reactions because the acid and the base cancel out and you go from something with a low pH, the acid, and something with a high pH, the base, and you can add them together and eventually you can make a solution that's neutral. And that's why it's called a neutralisation reaction. They'll react together and the base removes those free hydrogens that we were talking about from the solution, so the solution becomes less and less acidic. It joins them up to make water, which has a pH of 7, that's neutral, and the bit of the acid that's left behind joins on to the other bit of the base, the metal in the base, and forms a salt. To investigate neutralisation, we are going to use this special lab equipment, and this is called a burette. Very narrow cylinder. It's a very accurate way of measuring volumes of liquids, and at the bottom there's a little tap, and I can let a tiny little bit of this liquid out when I open tap, shut tap, and know exactly how much of this I need to add to whatever I've got in my conical flask for a reaction to happen. This method is called a titration, and it's used in labs every day across the country to determine concentrations of different solutions. If you're going to do A-level chemistry, you'll get bored of the sight of these at university, do them all the time. So our burette, our really accurate way of measuring the volume of liquid we're going to have in our reaction. We react with something at the bottom that we've measured using a measuring cylinder, so we know the exact volume of that as well. So I've got my titration set up. I've got my alkali, my sodium hydroxide solution, in my burette, and I've measured with a measuring cylinder 25 centimetres cubed of hydrochloric acid, and that's in my conical flask. I'm going to put some universal indicator in my conical flask. We'll be able to use this to determine when we've fully neutralised our solution. So, if I open the tap, I can let a little bit of sodium hydroxide into our conical flask. Swirling, chemistry technique, I love that. I'm going to add a bit more. See, and the colour of our universal indicator starts to change. So you can see at this point, starting to get a colour change by universal indicator. It's gone from red to orangey yellow, so the pH is increasing. We're getting near the point now where the alkali, the sodium hydroxide, has almost neutralised the acid. See, if I add a tiny bit more, see part of that solution is a blue colour. I swirl it to make sure it's fully reacted. It might go back. Now I would say actually I've gone a little bit beyond pH 7 there. pH 7 is a very green colour. This is ever so slightly blue. I can take a measurement of my burette and see that I have added a little bit over 25 centimetres cubed of sodium hydroxide. So my 25 centimetres cubed of hydrochloric acid has needed maybe a little bit less than 25 centimetres cubed of sodium hydroxide to neutralise it. If I keep adding alkali to the solution in my conical flask, that solution will become more alkaline. And we can see this if I add a little bit more. Definitely turning fully blue. So we can try this again. Now I've got a reasonable idea of how much sodium hydroxide I need to add. I can add that quickly, and then when we get near the neutralisation point, I can add it much more slowly and get a really accurate idea of how much I need for the reaction to be neutralised. So I've got carefully measured 25 centimetres cubed of hydrochloric acid, again in my conical flask, a few drops of universal indicator. So I know that I need about 25 centimetres cubed of sodium hydroxide, so I can add probably the first 20 centimetres cubed quite quickly. You can see that in the conical flask we've got different colours of universal indicator there because the reaction's happening all over through that solution. If I swirl it, we can mix it up. So I've got near the end point now where I should be able to make my solution neutral, so I'm going to start adding my sodium hydroxide a bit more slowly. So it's close then, it looked like it might be green, but when I've swirled it, it's gone back to yellow. I'll add a few more drops. See, actually if I put it down, I can literally add 1 or 2 drops at a time. It might be red. This allows us to be really, really accurate in our measurements. Really close. Add 1 drop more, see? We've got a solution. It's pretty much pH 7.